Hi and welcome back. This is Pankaj here, and we have been doing a lot of videos on probability. By now, I'm sure you would have seen all the videos on probability, and I'm glad that you actually did that, because this actual video is going to have a lot of proofs and concept in it. There's going to be one proof that I'm going to do right now in this video, and believe me, you're going to watch this proof again and again. Okay, if you are really interested in understanding the concept behind it, I'm sure you would watch this twice at least. Okay, so let's start off and let's look at what I'm exactly talking about. Let me erase this first and get ready to start. Okay, so I have been doing conditional probability, right? I have been telling you that the probability of A given that B has occurred is equal to what? Probability of A intersection B divided by probability of B. Now, this is something that I explained to you, isn't it? Okay, can I write this as probability of A intersection B is equal to probability of A given that B has occurred into probability of B? I can do that, right? I just transposed it to the left hand side and I wrote it like this. Okay, now let's understand the word independent events. Independent events. Okay. What are independent events? It says what it is. Basically, these are events which can happen independently of each other. The events does not affect each other. That's the main point. They do not affect each other's occurrence. What am I talking about? Let's say, for example, now you're watching this video, right? Is that anyways going to affect the sunrise tomorrow or the sunset in the evening? No, right? These are completely independent. They have no reason why these should be affecting the probabilities of these two happening, correct? So those are my independent events. Okay, let's look at one more example. Let's say, for example, it's gonna rain tomorrow, okay? Tomorrow it's gonna rain and me preparing coffee today, that has no connection to each other, right? There's no connection with each other, so it's going to happen independently. No matter what I do with the coffee, or tomorrow is going to rain or not, I'm going to prepare my coffee, and preparing coffee is not going to affect the rain. Okay, so those are independent events. Let me give you an example of dependent events. Now, you listening to this video, that might affect your marks in your examination. If you understand the concept, you will be in a better situation to score good marks. Correct? So there is, I'm not saying that there's going to be huge dependency, but yes, there will be a slight amount of change in the probability of you scoring marks. Correct? Now that's what I'm talking about. So dependent events are those, and independent events are those where there is absolutely no dependency to each other. Okay, it's fine. So why am I saying that? Now let's look at this. I said probability of A intersection B is going to be equal to probability of A given that B has occurred. Say what, for example, A and B are independent, which means occurrence of A or occurrence of B has no effect on A, and occurrence of A has no effect on B, which means probability of A given that B has occurred will simply be equal to probability of A, isn't it? So I can now write this as probability of A into probability of B, and that's it. So what is this? I've just gone ahead and proved that if two events are independent, then probability of A intersection B is going to be equal to probability of A into probability of B. Now, please do not confuse this independent events to mutually exclusive events. Okay, mutually exclusive events are something else, and independent events are something else. They have I wouldn't say they are not connected to each other, but these are two different entities altogether. What are mutually exclusive events? Events which do not occur simultaneously. Basically, A intersection B is a null set. That is a mutually exclusive event. Whereas when I'm talking about probabilities, and this is the only way to find out if two events are independent, okay, there is no other way. Okay, fine. Fine. So what is the connection or the relationship between mutually exclusive or the disjoint events with the independent events? Now that's the proof that I was talking about. Okay, now I'm sure you're not going to get this for the first time, but if you get it, you've been good. You've been doing good amount of questions on probability, and your concepts are really great. And if you don't get it, do not worry. I didn't get it for the first time. I really had to do it like 2 to 3 times to get the knack or get the idea behind the proof. Okay, and this is not there for your syllabus for CBSE nor for ISC. Okay, it's just good to know information for you. Okay, fine. Let's go ahead. So I have mutually exclusive events at one hand, and I have independent events in the other hand. Okay. Now, what I'm going to do right now is to take A and B, two events, and I'm going to say that they are disjoint. Basically, I'm going to say that they are mutually exclusive. Now, when they are mutually exclusive, obviously I do know that A intersection B is a null set. Correct? A intersection B is a null set. Now, I'm also saying that A and B are positive probabilities, which means they're going to happen. Okay, it's not a null event. Okay, so probability of A will be greater than 0, and probability of B is also greater than 0. So given this condition, I'm taking this into consideration. Okay, so I've also gone ahead and proved that probability or A intersection B is a null set, which means probability of A intersection B is going to be a 0, isn't it? Because n of A intersection B is a 0 divided by n of S. No matter what that is, it's going to give me a 0. Correct? Okay, so I also know that probability of A intersection B can be written as a probability of A into probability of B given that A has occurred, and or I can also write this as probability of B into probability of A given that B has occurred. So these are my two conditions, correct? Fine. I do know that probability of A is not equal to 0, correct? And I also know that probability of B is not equal to 0. I defined it such way here, isn't it? Now, when that's the case, and I just proved that probability of A intersection B is equal to 0, right? Then I'm saying that probability of A into probability of B given that A has occurred is equal to 0. This cannot be equal to 0. So probability of B given that A has occurred is equal to 0, right? Which is not equal to probability of B. So what is happening here? So if I'm looking at the probability of B standing alone, then it is not equal to a number, it is some other number. But when event A has occurred, then I'm checking the probability of B, then it's giving me a 0, which means A is affecting the probability of B. Similarly, I have probability of B into probability of A given that B has occurred. Well, that is going to be equal to 0. Why? Because I've just gone ahead and proved that probability of A intersection B is 0. And this cannot be a 0 because my condition doesn't allow me to do that, and so this is equal to 0. So probability of A given that B has occurred is equal to 0, which in case is not, in turn, is not equal to probability of A, because probability of A is greater than 0. That's a condition I had taken, right? Now when I come back here, standalone probability of A is greater than 0, but when B has occurred, the probability of A changes, and that is why it's a 0, right? What does this tell me? This tells me that A and B are affecting each other's probability, and exactly why A and B are dependent on each other. They are dependent events. Okay? Fine, which means occurrence of one of them affects the probability of the other. So what have I just gone ahead and proved? That I have proved that if A and B are disjoint sets, there's no common elements between them, then the events are going to be dependent. Perfect. Let's move on. Okay, so they're always going to be dependent if they are mutually disjoint events. Now, let me consider a situation that A and B are independent. Okay, I'm going to put a condition that A and B are independent, and I'm also going to say that probability of A is greater than zeros, and probability of B is greater than zero, which means they are not null events. They do produce some output. Okay, then if they are independent, we just went ahead and proved that, in the previous proof, we had probability of A intersection B as probability of A into probability of B, because they don't affect each other. Now, what does this apply? This implies that probability of A intersection B, because this is a non-zero element, this is a non-zero entity, this will be a greater than zero entity, which means A intersection B is greater than zero, which means there is elements in A intersection B, right? Now, what is that telling me? It tells me that two events which are independent, they cannot be mutually exclusive. Okay, fine. Now I'm sure you would have gone back, or you would have completely lost it, right? Happens. The proof is like that. Okay, let me tell you what exactly I proved here. Okay, let me take a mutually exclusive here. Mutually exclusive. And let me take non-mutually exclusive. Non-mutually exclusive. Okay, and I'm going to write independent. And I'm going to write dependent here. Alright, so if they are not or mutually exclusive, they're always dependent events. Okay, mutually exclusive are always dependent events. Now, independent events are always not mutually exclusive, and they can also be dependent events. Okay, so this is exactly what I explained. Now please go back, look at the proof, and try to understand this once again. Okay, so what I'm going to do here is, let me tell you very frankly, when I initially started off doing probability, I had a major confusion with mutually exclusive and independent events. I had a big headache, in breaking down that these two are actually separate. I had to refer to multiple books and go online and find out and research on that, and then come up with this proof. Okay, right, as I said again, you don't need to know this. You don't need to know the proof. It's a good to know information. At the end of this video, if you just keep this in your mind that mutually exclusive events are not independent events, that is more than enough for me. Okay? Perfect. Now with that, I'm going to stop this video because I know that there's a proof in this which needs to be repeated again and again. So I'm not going to add any more stuff to this video. In the next video, I'm going to pick up more questions and do them. Okay? Thank you. And please share the video and subscribe to it. Any suggestions or any questions that you want me to solve, please put that up in the comment sections. Thank you very much and goodbye.